Okay, now that we have an understanding of atoms, we're going to look at how understanding atoms, the basic building blocks of matter, help us predict what substances are out there in our universe. So this is Learning Target 17. Use the particle model of matter to illustrate characteristics of different substances. Okay, because of our understanding of atoms, we were able to develop a particle theory of matter, which is basically a particle as an atom. So the particle theory of matter has certain characteristics about it that we have found to be true in our universe. So what we found out is all matter is made up of tiny particles called atoms. So anything that is matter is made up of atoms. These particles have empty spaces between them, and they move randomly anywhere all the time. So atoms have spaces between other atoms, and they move around all the time. That means they have kinetic energy. Particles move faster when kinetic energy increases. So the more kinetic energy matter has, the faster it'll move. Atoms attract each other, or particles attract each other. That's what's creating those bonds to form compounds. And each substance or each atom has unique properties. So we saw that when we looked at the periodic table. Each element had a certain number of protons that was a unique property to it. So particle theory of matter came about after our understanding of what atoms were. We were able to come up with some characteristics about matter that we know to be true based on our studying of atoms. And that is called the particle theory of matter. Okay, the particle theory also helps us define what a solid, liquid, and gas is, because it's based on the kinetic energy those atoms or particles have. So a solid, if you look over here off to the right-hand side, okay, a solid has the least amount of kinetic energy. The particles are arranged in fixed positions and they're close together. The only type of movement that solids have is vibrational movement. So they have the least amount of kinetic energy. So we know, based on how the atoms are arranged, we can look at the atom arrangement and say that's a solid. Then when you have particles that are in clusters that are free to move or flow, they're still close together, but they're allowed to move freer, that's a liquid. And then a gas has a lot of empty space between the particles or atoms. They have complete freedom to move, and they're very far apart. We know that is a gas. That means that matter is in this phase of a gas phase. So let's take a look at those. Pull it over, didn't realize that was, there we go. A solid. Particles are, and whenever I say particles, I'm talking about the atoms. Particles are tightly packed. They have vibrational movement. They have the least amount of energy, the least amount of kinetic energy. Because they are packed tightly together, solids have shape, and they take up space, a specific amount, so they have volume. Now, because they are so close together, the attraction between those atoms or particles is the greatest. So that's why they stay in a certain shape, because they're close together and they're attracted to each other due to those positive and negative charges of protons and electrons in an atom. Now, if we take a look at a liquid, particles have more freedom, so they flow. Liquids flow. They have more kinetic energy. And because they flow, they don't take a particular shape, but they do take up a certain amount of space. A term that we use a lot, a term that we use a lot to describe a liquid is viscosity. It has to do with how a liquid will flow. It's its resistance to flow. So if a liquid has a high viscosity, then it doesn't flow very easily. Like maple syrup doesn't flow very easily compared to like oil, which flows very easily. So maple syrup would have a high viscosity, a high resistance to flow. Oil would have a low viscosity, a low resistance to flow. The last phase of matter is a gas. Particles have the most kinetic energy, and because they're moving around all over the place, they don't take a particular shape. That's why when you reach out and you're trying to grab the air around you, you can't grab it. And they don't take up a particular volume unless you contain it in a solid. If you right now, if you go outside, all the gas in the atmosphere is just moving around everywhere. So it doesn't take up a specific volume. It has the least amount of attraction between particles because gas particles are so far apart. So the farther apart, less attraction. And then the fourth phase of matter is plasma. It's a mixture between a gas and a liquid. Basically, the particles are moving so fast that they have similar properties from a gas to liquid. Lightning is an example of plasma, and plasma has the most kinetic energy out of all the phases of matter. Okay, so let's take a look at the phases of matter and how particles in matter change based on energy. So if you take a look at this, okay, we've got, and this up here at the top tells you which element we're using. We're using neon, okay. Neon, right now at this temperature, 13 Kelvin, is a solid. If we start to add some heat energy, so this is how energy can change matter. If we start to add heat, then you're going to see a change in state from a solid to a liquid. And then if we keep adding more heat, the particles get more kinetic energy. The more kinetic energy, the farther apart they are, and they start changing into a gas. Okay, let's look at argon. Argon is a solid at 43 Kelvin. You add heat, it's going to change from a solid to a liquid to a gas. The more kinetic energy the atoms have, the quicker they're going to change state. Then you can cool it, take away that thermal energy or that kinetic energy. Particles start to slow down. They start to get closer to each other. The attraction gets a little bit stronger, and then they start to form into a solid. Okay, now we're going to look at a compound. We're going to look at two oxygen atoms bonded together. See how they're bonded together, the two next to each other? Increase the heat. Those compounds of oxygen get more kinetic energy. They start changing from a solid to a liquid and then to a gas. Water. Let's reset all. Let's go to water. Is a compound, H2O. Now water, when it's in a solid phase, you see these little big spaces between them. Well, we get into this a lot in 8th grade, but this is one of the reasons why if you have very little mass, like a spider, they can walk on water because they don't break through that. If you don't break through the bonds between the other water molecules, you can continue to walk on them. And if you want to research why water, certain shape is like this when it's in a solid form and how that allows living things to walk on water, that might help you get above proficient on your left-hand activity. So if we add thermal energy, those particles are going to get more kinetic energy. They're going to change into a liquid and then into a gas. Cool it down. Okay, so what we just looked at, you saw different elements changing and compounds changing from a solid liquid to a gas. So that's what we call a phase change. So temperature measures the amount of kinetic energy and the speed of the particles. So remember, the more kinetic energy, then you're going to have a change in state. So that's what temperature measures. It measures how much kinetic energy those atoms have in matter. So there are different types of phase changes. Evaporation, when we go from a liquid to gas, that means kinetic energy is increasing. Melting, when you go from a solid to a liquid, kinetic energy is increasing. And you might want to put increasing instead of gained. Freezing, when we go from a liquid to a solid, we are decreasing kinetic energy. Condensation, a gas to a liquid, kinetic energy is decreasing. Sublimation is when you go directly from a solid to a gas, energy is increasing. Okay, so now hopefully you've got a better idea of what the particle theory of matter illustrates and how it helps us define and classify different substances using atoms.